Hello all and welcome to the algebra video for slope and the slope formula. Main things we're going to try to accomplish in this section are first talk about what slope is in a mathematical sense, and then also talk about the slope formula, which is an algebraic way to represent the slope when you have points of a line. Okay, so with that being said, we're going to jump right into it because this is going to be kind of a long section. But like I said, we'll go through the notes pretty quickly here, look at some of the examples, and really talk about what's really going on with these lines and what slope really means. Okay. So, the first definition that we need here, okay, and this is goes in the first blank on the top of the page there, is a definition of rate of change. Now, when you think about rate of change mathematically, okay, the definition here states that it's a ratio that shows how one variable changes with respect to another. Okay, that's mathematically the definition of rate of change. So, keywords here being ratio, meaning simply kind of like a fraction, not really a fraction, but you've got a number over another number, division-wise, okay? That shows how one variable changes with respect to another, okay? So one variable changes with respect to another. So in real-life situations, you could think of a rate of change as something like speed. Speed is a rate of change. So like speed of how fast you're going in your car. That's a rate of change because one variable changes with respect to another. So distance changes with respect to time. So how fast you go is basically just saying, okay, I drive this distance in this amount of time. That tells you how fast that you're going. Okay. And when we talk about rate of change, if we have a graph of a line, we actually have a special name for that rate of change, which is called the slope of the line. Okay. So in this case, once again, real world thinking here, this rate of change is represented on a graph by the slope. So if you have a graph of, once again, one variable and another, so in this case, if you've got a graph of distance and time, okay, or time and distance, then the slope of that line would be your rate of change. The slope of that line would be how fast you're going, okay? This also works in other situations like in terms of how many pizzas a bakery can bake in a day. Okay, well, if you plot that on a line, if you have a line of that, that's telling you basically another way of saying the speed at which people make pizzas per day. Okay, you think of a rate of change, the miles per gallon in your car, miles per gallon. That's a rate of change. That tells you can do drive so many miles on so many gallons of gas. Okay, miles driven over gallons of gas, which you can find rates of change everywhere in the real world. So you can relate two different variables in a bunch of different ways. But going forward, we are going to just specifically talk about this strictly mathematically, okay, for this section, meaning, which I might make a reference here or there where you can understand what this means in the real world, okay? But we're going to start, instead of rate of change, so this is a definition, we're going to make sure we call it slope, okay? And as we go through with slope, that's what we're going to reference this rate of change as going forward, which should, like I said, make this just a purely mathematic way to look at rates of change. Okay, so first things first here, you got slope. You notice there's a line drawn with technically three different points on it, which technically we all know, hopefully at this point, that a line actually has infinitely many points on it. So there's a point, obviously, at the places where the points are drawn. So here, here, and here. But there's also a point right here, or there's a point right here, or a point right here, okay? Or a point in between these 2 points. And that's the thing. There's always a point in between every 2 points. So that's why there's infinitely many points. And what leads to that as well is these arrows, meaning this line goes on forever in both directions, okay? So if you have a line The slope is written as a ratio. So once again, ratio, we see that word again since it's a rate of change of the vertical change. So we call this the rise to the horizontal change, which we call the run, between any 2 points on the same line. Okay? So what that means is it's a ratio. Vertical change is rise over, so that's what ratio means. We have like kind of like a fraction here, rise over run. Now, some of you maybe heard of this before, but all it's really saying is we can tell, so slope, we can tell how steep this line is. So what the rate of change is for whatever situation we're in, we can tell how steep this line is by taking how far you have to go up and how far you have to go over to get to another point. Okay? And I do want to point out here it's between any 2 points. Okay? So I just want to point out that the slope from this point to this point will be the same as this point to this point. Okay? Because if you go up, so let's do a quick one here together. So to go from this point to the middle point here, we go up 1, 2, 3, 4. So that tells me to go from this point to this point, the slope of this line is 4 over. Well, how far now to the left or right do I have to go? I have to go over 1, 2, 3, 4. So in this case, we get the ratio 4 over 4, which simplifies to the number of 1. Well, that's what we get when we calculate from this point to this point. So we just went 1, 2, 3, 4, 1, 2, 3, 4. We counted up and over, which is, once again, rise and run. Rise is how far up or down we have to go. Run is horizontal. That's what vertical and horizontal mean. So up and down, left or right. Vertical, horizontal. But if we calculate the same thing here, well, how far do we have to go to get from here to here? Well, we have to go up 1, 2, and then we have to go over 1, 2. Well, what does that fraction or ratio simplify into? Well, that simplifies also to the number 1. So in this case, we took technically 3 different points here, and the slope between these 2 points actually calculates to be the same as the slope with these 2 points. So that's the point I wanted to make here, no pun intended, that the slope, it doesn't matter. If you've got a straight line, okay, once again, linear graph, if you've got a straight line and you calculate the slope between any 2 points, you're always going to get the same number, okay? And that's what this point right here makes is this remains constant for any 2 points on the same line. And we just demonstrated that because we went from this point to this point, well, the slope was 1. We went from this point to this point, well, the slope there was 1, okay? And that's literally just from counting. So if you know how to count, you can do the slope if you've got the graph because you can go from this point to this point by just counting up. 1, 2, 3, 4, and over 1, 2, 3, 4. So 4 over 4. The slope in this case would be up 1, 2 over 1, 2. So 2 over 2. We could even go and say, well, let's go from this point to this point. Well, how far do we have to go up? We have to go up 1 over 1. So that would be 1 over 1. So you can actually count up and over between any 2 points. We can go all the way up here. So we can go up 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. To go from this point to this point, it would be 6 over 6, which would also be 1. So this is what we have right here in terms of the first way we're going to talk about slope, which is rise over run. And the last point to make on this page is slope is written as a fraction in simplest form, meaning, okay, well, we wrote these fractions, 4 over 4, 1 over 1, 2 over 2, but the simplest form of these would just to be to write the number 1, because 2 over 2 or 2 divided by 2 is 1. 1 divided by 1 is 1. 4 divided by 4 is 1. So that's what it means by simplest form. We need to simplify our fractions as low as we can make them. In this case, the lowest we can make it is just the number 1. Okay? So a lot of information we just packed at you in that one slide. Okay? A couple more pieces of information here before we go on to Some examples. It's kind of a weird variable here, but we do have a variable that we specifically use for slope. So in algebra specifically and in math in general, if you see the letter M, usually that stands for the slope of a line. Now, why is it M and not S? Why is it, not R for maybe ratio or rate of change? I really can't say for sure. There is kind of a little tell that the variable slope comes from a French word which means to climb or to go up. So in this case, that word is monte, okay? And since it starts with an M, that's what they use for slope, okay? Now, how true is that? I'm not sure, but just by tradition, just by what we know, the variable for slope that we're going to use is always M, okay? Now, the last thing that we need to talk about here before we actually jump into some equations of calculating slope is the piece of information here is the types of slope that we have, okay? And just by the way, so this is the cool thing about a line, is if you have a line graphed, just by the way the line looks, you can actually tell a little bit about the slope without actually counting anything. My point here is if you have a line that looks like this, so it goes from left to right and it kind of points up, so you can kind of see going from left to right, the line shoots up this way. So from bottom left to top right, we say that a line that looks like this has positive slope, meaning the number you're going to count when you do rise over run, it's going to be a positive number. Well, if you know this kind of line is a positive slope, you can maybe deduce that this kind of line going from top left to right bottom, okay, that's going to be a negative slope. And you could probably guess if a positive slope has a positive number calculated, well, then the slope you calculate for a negative slope line is going to be negative. That's why we call them positive and negative, okay? So the way to think about it is up. So up from left to right is positive. Down from left to right is negative. And then we have two kind of special cases here, okay? And these can kind of get a little tricky. But the way that I think about it is, well, if we have a horizontal line, well, if you were looking at a mountain, well, it wouldn't be much of a mountain if it looked like this, right? So a mountain that looked like this, you could kind of see the slopes of a mountain. They're kind of slanted. Well, this looks more like Kansas or Nebraska or something. It's flat as a pancake, okay? Well, if you have something horizontal across like this actually means the slope is zero. So we call this zero slope. Oh, not zero stope, zero slope. So let me start that again there. Zero slope, okay? And that is represented a lot of times when we calculate it by just the number zero, okay? And you'll see why when we get to calculating slopes, why it is zero here in just a moment. But then let's go and look at the last line here, the type of slope we have here. Well, if this is positive, this is negative, this is zero, well, we kind of have to ask what's left. We got positive numbers, negative numbers, so positive slopes, negative slopes, zero slope. What's left? Well, that's kind of the point. There's actually nothing left in terms of types of numbers. So we can have positive numbers, negative numbers. We can have zero, which is neither positive nor negative. But this is what we would call undefined, meaning we don't know what this number is for slope, okay? Sometimes you might see people call it infinite slope, but that's actually not a good way to think about it. Even though if you do think about it, straight up and down, that's like as steep as you can get. It's the most steep, so straight up and down a wall. But we call this undefined because what we'll end up having is we'll get a number for the slope that we actually can't calculate. And once again, you'll see why when we look at some of these examples. Another way to think about undefined is just like we say zero slope here, you could also say that undefined is no slope. Okay, so people do tend to get confused here. So I just want to point out zero slope. So if you use the number here, 0, that means you have a flat horizontal line. If you're told that a line has no slope, okay, that means that the slope doesn't exist. That means the number is undefined, which means you have a vertical line, so a straight up and down line, okay? And that's the thing. A lot of these lines, you can actually tell a lot about them, as we'll see in the examples, by just looking at which way the line points. Does it point up to the right? So is it positive? Is it negative? Is it 0? Or is it undefined? Okay, and that's what we'll look at with all of these examples. So notice here, these are the graphs that are exactly the same as what's on your paper there. So when you look at this, finding slope on a graph, okay, well, first things first here, we have m is equal to, well, what I want you to write in here is rise over run, okay? So what this does for us is this allows us to see, well, what are we actually calculating here? Well, all we're doing when we want to find the slope of a line, if we have the graph, all we have to do is literally count. How far up or down do we have to go, and how far left or right do we have to go? So how far vertically we have to go, how far horizontally we have to go. So with that being said, if we look at number 1, they give us 2 points. They give us this point and this point. Now, I do want to point out we don't technically have to use those points. We could use this point right here and this point right here. Okay, we could use this point right here or this point right here. You can use any points you want to, okay? The only problem is if you don't use a point that's immediately on a grid line, it kind of gets hard to count. So with all these examples, pretty much all these examples, you're given 2 points to kind of help you see, well, these are the points we need to look at. So if we're going from this point to this point, well, it's the same kind of thing. So I'm going to use a different color here so it can stand out. I'm going to go from this point to this point. So that means I'm going to have to count up and over, meaning I'm going to go up 1, 2, 3, 4, 5, 6, 7. So what does that tell me? That tells me my rise is 7. So we ended up here. Well, now how far left or right do I have to go? Well, I have to go to the right, obviously, so it's over here. So I have to count 1, 2, 3, 4. And that tells me, and that's actually it, because I can't simplify that fraction, okay? And that's what this point right here, write your answer in simplest form, okay? We can't write that any simpler. We can't divide 7 by 2 or 7 by 4. We can't divide 4 by 7, okay, or vice versa. So in this case, 7/4, that is the slope, okay, and we get that just directly from this idea of rise over run. And that's pretty much it. Now, one thing to keep in mind, as you'll see through going through these examples, usually what you have is the steeper the line, the bigger your number is here. So in this case, this is actually a pretty steep line because if you look at this as a fraction, 7/4, you actually get something bigger than 1. And usually we say things that have a slope of bigger than 1. Those are actually things that are pretty steep. So just try to think about trying to climb up a slope like this. If you were mountain climbing and you came across a piece of land like this that you had to climb up, that would be pretty hard, okay? So that's technically, you can kind of make synonymous with slope as kind of how hard it is to climb up a slope like that or up a mountainside. It'd be pretty hard to climb up this one. This one actually wouldn't be too bad because you can actually, if you were going down the slope, okay, it makes kind of like a little ramp here. But with number 2, same kind of thing. We want to go from this point to this point. Well, how far up or down do I have to go? Well, from here to here, I have to go down. So I'm going to count 1, 2, 3. So I have to go down 3. So my top number is 3. All right, well, left to right, what do I do? So I go over 1, 2, 3, 4, 5, 6, 7, 8, 9. But here, so if we go back, so first off, we see we got a fraction here. Something a little weird about this fraction. We're actually going to have to simplify it. But the other thing that I do want to point out is if you look at number 1, look at this line compared to this line. They look pretty similar. So that makes sense that we got a positive 7/4 here as our number. But on this one, we can see this line actually goes down from left to right. So that actually tells us our slope should be negative. So just by the way that this line is, we know that our answer here should be a negative number because our slope is negative. But once again, we're still not done. This is negative 3/9, so it's still negative. But now we have to simplify fractions, and I'm going to assume that you already know how to simplify fractions, so I'm going to go through this pretty quickly. But just to explain how we do this, you take the greatest common factor of the top and bottom, and you divide both numbers by that number, meaning 3 divided by 3 is 1, 9 divided by 3 is 3. So in this case, our fraction, or our slope in this case, is negative 1/3. And we know it's negative because the shape of the line, meaning it's pointing down to the right. Okay, so up to down from left to right. This one's down to up, left to right, so that's positive. Okay, and then the next two here should be pretty easy, considering if you know just how the lines look, you can tell what these are. We can already say, all right, this is a horizontal line, that's zero slope. We're done. Okay. But I am going to go ahead and calculate that to show you why. Well, if we want to go from this point to this point, okay, well, then we have to go up or down 0. So my rise is 0. So I hope everybody can agree with me. If I was going from here to here, I don't have to move up or down. I can just go left to right. So that means I go up or down 0. Well, how far left or right do I have to go? Well, I have to go right 1, 2, 3, 4. And if you actually calculate that, 0 divided by 4, a lot of people get confused by this, but 0 divided by any number other than 0, okay, so you can't have 0 over 0. But in this case, you have 0 over 4, that's just 0, okay? That's actually the number 0. That's why we say this has 0 slope, okay? On the other hand, let's look at number 4. Well, if we look at number 4, that looks very similar to this line right here, which is up and down, which we say is undefined slope. So what does that mean? So once again, we already know this is undefined slope, but let's calculate that and really see what that means. So let's say we have these 2 points, and I want to go from this point to this point. Well, first off, to go from here to here, I'm going to have to go up 1, 2, 3, 4, 5. Okay, once again, that's my rise, how far up or down I have to go. So in this case, I had to go up 5. Well, what's my run going to be here? Well, if I go up 5, I'm actually already at that point. I don't have to go left or right at all. That means my run is actually going to be 0. I don't have to move left or right. Here's another place where a lot of people get confused. 5 divided by 0, that's not 5. That's not 0. Now, I challenge you, go ahead and try this out on a calculator. Do 5 divided by 0. You'll actually see that that doesn't make sense at all. Your either calculator will either say error, meaning it can't calculate it, or it will say undefined. Okay, so this actually has undefined slope, meaning the slope can't be calculated. And you can see that because try to calculate 5 divided by 0. You can't do it. So another way to say this is it has no slope, which means we literally can't figure out what the slope is because we can't calculate it. Okay? So when we say no slope, it means there's actually no slope. We can't give it a number. But when we say 0 slope, once again, in math, when we say 0 slope, that literally means when we calculate the slope, it's actually 0. Okay? 0 over 4, 0 over 10, 0 over 53. Okay. Once again, 0 over any number, other than 0, is always going to be 0. Any number over 0, well, this should be a very common thing for everybody, but like I said, people still get this wrong to this day. If you divide by 0, that is not a number. Okay. 5 divided by 0 is not 0. It's not 5. It is undefined, meaning you can't calculate it. Because if you know how division works, that's like saying I've got 5 cookies and I wanted to divide it into 0 groups. Okay. Well, it doesn't make sense to have 5 cookies and divide it by 0 people. Okay. You can't divide 5 into 0. Like you can't, or 0 into 5. You can't divide things into 0 piles. Okay. Unless you, I guess, just destroy the cookies or whatever. But that once again, that doesn't really make sense in what we're doing here. So just know, you ever divide by 0, the slope is undefined. Okay. So what I'm going to have you do is, if you if you pause the video, would be pretty nice if you would go through and do so. If you go through numbers 5 through, I believe it's 12. Let me double check here. And then 5 through 16. So a lot of questions here. But if you go through 5 through 16, go through, practice this yourself, calculate the slope, and then come back to the video after you're done and check and see if you got them right, okay? So I'll pause just a second to let you pause and work through these, okay? So once again, calculate your own slopes and come back to the video and check and see if you got them right. So let's go ahead and look at number 5 here, okay? Number 5, first thing I notice is we're going to have a positive slope. So my number, if you want to, maybe put a little something over here. I know my number is going to be positive, okay? So, well, what's the number actually going to be? Well, they were nice enough to give us 2 points. We can use this point and this point. We don't technically have to use this point. We could have used this point down here, okay? Or we could have used, once again, this point right here, or this point right here. But once again, it makes sense. We don't, only way we can really count is if we use marks right on the grid. And they were really nice enough to give us these 2 points. But so at this point, we want to go here to here. So we got to go up 1, 2, 3, 4, 5 over 1, 2, 3. And that's it. We can't simplify that fraction. That's a positive fraction, so we're done. Okay, that's as simple as it is. Just count up and count over. Or in some cases, as you'll see here, count down and count over. Because that's what I'm going to do with number 6. I go from here to here. That means I have to go down 1, 2, 3. And go over 1. But one thing that I didn't mention there is, let's look at the line. Well, this isn't going to be positive 3 over 1. So if you look, this line points down from left to right. So it's going down, okay? So if you need to, make a little mark over here saying it's going to be negative. So we know this is negative 3 over 1. We can actually simplify this because 3 over 1 is just 3. So my final answer here is just negative 3. Okay? But once again, the hard part about this is probably simplifying fractions. But the rest of it is notice whether you should have a positive or negative slope and just be able to count. All you got to do is count places. Now, I do suggest, so you can't really see, my hand working on the pad here. But what I'm doing, and you can find a color, see by the cursor, is, especially if you have this on paper, literally write it down. So first off, I know this slope is positive. But what do I do? So what do I mean by write it down? Well, just literally put your pencil down and say, I'm going from here to here. So I have to count up 1, 2, 3, 4. And then I have to go over 1, 2. Well, once again, that's a positive fraction, which is good. Okay, once again, we can just tell that by the shape of the graph, like which way it's going. But we can simplify this. 4 divided by 2, that's actually just 2. So to speed this up a little bit, number 8, we're going from here to here. First off, we know it's negative slope because we're going down this way, okay? So we know here we need to go 1, 2, 3, 4. Okay, so 4, but we know it's negative, so negative 4 over 1, 2, 3, 4. Well, that actually simplifies. And if you go back to what we very first thing we talked about was, okay, rise over run is a ratio. Well, look what we had here. 4 over 4, 1 over 1, 2 over 2. All those simplified to 1. So this would be negative 1. And once again, the whole reason we know it's negative is look at the way the graph is pointing. Okay? It's pointing down to the right. So that means it's a negative 1 slope. Number 9, we see that that's negative slope as well. We're going from this point to this point. So we're going to go down 1, 2, 3. Once again, negative 1, 2, 3. 1, 2, 3, 4. And that's actually as far as we can go. We're good on the negative aspect because it's pointing down. And then we can't simplify the fraction 3/4, so it has to stay 3/4. Number 10, this one's a little harder, but you can see it actually does point down. Okay, the arrow got a little bit knocked off there, so the arrow should be right there. But in this case, we go from here to here. That means we are, once again, going down, so our slope's negative. So we're going to have negative, we'll go down. 1, 2, 3, 4, 5. And go to the right 1. So same as last time when we had the slope negative 3 over 1, that ended up being negative 3. Negative 5 over 1 is just the number negative 5. Then we get to number 11. And once again, you technically shouldn't have to do any calculation on this one because you see the line. It's going straight up and down. That should be an automatic indicator that this is undefined. It does not have a slope. But if you were curious and you wanted to calculate it, notice here they don't even give you 2 points. But I'm going to choose 2. I'm going to choose this one and let's say this one. So if I want to go from this point to this point, well, I'm going to go up 1, 2, 3, 4, 5, 6. So I'm going to go up 6. Well, how far left or right do I have to go now? Well, 0. Well, what's 6 divided by 0? It's undefined. Okay. And you could have had a different number up here because you could have chosen this point, or you could have chosen this point, or you could have chosen this point, or this point, or this point. Okay. You could have chosen any points on the line. It actually doesn't matter. But if you go in between any 2 points, it doesn't matter because your bottom of the fraction, so your denominator, is always going to be 0. So that means it's always going to be undefined. Number 12 here, we know that the slope should be positive. Okay. So we're going from here to here. So that means we go up 1, 2. And we go to the right 1, 2, 3. Not 2 over 2, 2 over 3. And that's as far as we can go because, once again, that is the most simplified version of that fraction. Number 13, once again, to speed this up, because, like I said, this is actually pretty easy. If you can count and simplify fractions, that's pretty much the point about this is if you've got a graph, you can find how steep the line is by just counting and knowing, does it point up or does it point down? So in this case, we've got these 2 points. We're going to go up 1 and go over 1, 2, 3, 4. And that's it, 1/4. We know this is going to be negative, so we go, in this case, down 1, 2. So negative 2 over 1, 2, 3, 4. Well, that fraction actually simplifies to be negative 2 over 4. So divide by 2, divide by 2. That fraction is 1/2. So negative 1/2. Mark those out there so you can clearly see how I counted. So down 2 over 4. 15, see it's going to be a positive slope from here to here. We go up 1, 2 over 1, 2, 3, 4, 5, 6. Which, once again, we can divide both top and bottom by 2. So we get the fraction 1/3. And lastly, this should be one of the easiest ones. If you ever have a horizontal line, notice once again, they didn't put any points on here. So just by the looks of this line, you know that this has a slope of 0. So you can say 0. You can literally write out the word 0. But just so you can see, let's choose this point and this point. Well, if I was going from here to here, that means I would go up or down 0 over, well, I would have to go over 1, 2, 3. So my slope is 0 over 3, which is 0. Like I said, you don't actually even have to do the calculation in that if you see a horizontal line like this, so one that goes straight left or right, okay, then that's just automatically, you know that that's 0 slope. Okay, so that's pretty much it in terms of finding slope with a graph. Now, we have another way that we can find slope, okay, and this is what makes this video so long because we went over that all that stuff. But we actually had, so that was kind of like a visual way where literally all you had to do was count, okay? But now we're going to introduce a formula. And the slope formula allows us to calculate slope between, once again, any 2 points without actually having to have the graph. So we're not going to have the graph, but we are going to be given 2 ordered pairs that actually we're told are on the line or on the graph. But if we don't have the graph to look at, we can't count and say up and over. So what this formula actually does is it allows us to do that. And we'll get into the formula here in just a second, but the top part of the formula is going to count how far up or down you have to go. The bottom part of the formula counts how far left or right you have to go. So this is still technically rise over run. It's just written in an algebraic way, meaning, okay, let me use variables and let me plug in things so I can figure out what the slope is, okay? So let me use variables, let me use unknowns to figure out something that I can figure out. So that's why algebra is full of solving equations, okay? Basically, in this case, we're going to be not really solving many equations. We're technically solving equations here because we're going to plug in y2, y1, x2, x1, and then when we simplify all that and do order of operations, that's going to give us what m is, okay? But I do want to point out, okay, so I want to be very clear on this, okay? So first off, let me lay out the whole formula here. We have m, which once again, remember, is slope. That slope is equal to y2 minus y1, and we say y1 or y2 or y sub 2 minus y1 or y sub 1. All of that over, so fraction bar here, x2 or x sub 2 minus x1 or x sub 1. Now you might be asking, well, what do these 1s and 2s mean here? I want to be very clear on this. These are not exponents. So this does not mean y squared. This does not mean x squared. This does not mean y to the first power. This does not mean x to the first power. What these little subscripts, and this is what these are called subscripts, okay? What these mean are which point did you take these coordinates from? Meaning, okay, here's my first point. That's x sub 1, y sub 1, okay? So the 1 here indicates that it's point number 1, and the 2's here represent that this is point number 2. Okay, and that's all that is. They're just labels because we actually have, if we have 2 points, if we remember 2 points, our points are always written in the form x comma y. So x coordinate, y coordinate. So instead of calling one coordinate something and the other coordinate something else, we just call them x and y. So they're 2 x's and 2 y's. But instead of getting confused and say y minus y, well, that doesn't make any sense. That would always be 0 if we said y minus y. But y2 minus y1, once again, we're saying this is a different y from this one. This is a different x from this one. And that's told by what the points are. Okay. So once again, you got to remember points are of the form x comma y. So that means the x coordinate for this point is 4. The y coordinate for this point is 3. And that's what we're going to use to actually plug into our formula. And without even looking at a graph, without having an equation, I can tell you that if a line has 2 points on it, and once again, this works for any 2 points, then you can calculate the slope by just knowing the points. Okay? So, the other big thing here is to know always simplify your fractions. Okay? Always simplify your fractions. Just as always, we had to simplify fractions before. You got to do it here too. Okay? So let's go on here. So I'm going to switch back to black so we can, because we're doing more algebraic stuff now. So it's not, you don't have any graphs here whatsoever. So the whole point here is we're given 2 points. You're told these 2 points are on the same line. And the instructions say find the slope between each pair of points. Meaning, if there's a line that goes through the point 1, 1, and there's a line that goes through the point 4, 3, well, knowing those 2 slopes, we can actually, or 2 points, we can actually just calculate the slope by using this formula. Now, I do want to say, as far as this goes, this is a formula that will not be on your formula sheet. So this is a formula you just have to know. So my strong suggestion is every single one of these questions, you should write down your formula. Okay? So write down the formula every time because this is one you just have to know. Well, once again, kind of looks a little weird with all these subscripts, so 2 and 1, all these 1s and 2s. But all it's literally saying is if we call this point point 1 and we call this point point 2, y2 is going to be the y coordinate from the second point. Okay? So this is y2. Minus, well, y1 is going to be the y coordinate from the first point. Well, here's the first point. The y coordinate is 1. Over x2, well, it's going to be the x coordinate from the second point. So that's 4 minus x1. So we want the first point's x coordinate, which is 1. And now that's, to me, the hard part. Now all we got to do is do these calculations. 3 minus 1, well, that's 2. 4 minus 1, that's 3. That line has a slope of 2/3. Okay? And that comes strictly from just knowing the 2 points and knowing the formula. If you know the formula, you can plug this in. Once again, y2 minus y1, x2 minus x1. And these 1s and 2s just tell you which points you come from. Now, it actually doesn't matter. So those of you, I don't mean to confuse anybody by this, but it actually doesn't matter which point you call point 1 and which point you call point 2. As you saw with some of these questions back here, this point to this point, I always went from left to right or up to down, okay? Or in this case, up, down to up. But it actually doesn't matter which 2 points that you choose. When you calculate the slope, you should always get the same slope. That's what this means right here, where this remains constant for any 2 points. But once again, these 2 points, you can flip them around. It doesn't matter. Whichever 2 points you want, you're always going to get the slope of 2/3. Okay? But like I said, the main point here is the slope. So I'm going to go ahead and write the slope formula again for this one. So you're told these 2 points are on the same line. What's the slope of the line? Well, it's the same kind of thing. I'm going to call this point point 1, this point point 2, and then we just fill in what we know. We know y2 is -2. We know y1, so minus y1, which is 4, over x2, which is 10, minus x1, which is -2. Now, this is a place where people can kind of get a little tripped up. -2 minus 4, that's actually -6. Over 10 minus -2, you got to be very careful here. 10 minus -2, that's actually 12. Okay? But we see we got a negative over a positive. So to finish this out, this is what I mean by simplifying. Negative over a positive will be a negative. 6 divided by 12, well, I can divide both of those by 6. So that's going to give me the fraction negative 1/2. So once again, without even looking at the line, so without looking at a graph of a line, you can figure out that the slope between these 2 points is negative 1/2. So to kind of pick it up here, and that's the way all of these questions work. y2 minus y1 over x2 minus x1. I'm going to call this one 0.1, this one 0.2. Okay, so that means my y2 would be negative 5 minus 5 over negative 8 minus negative 4. You can see how quick I was with writing those in because I kind of can see the pattern here. It's always this x value minus this, or this y value minus this y value over this y value minus this y value. And if you really think about what we're doing here, is we're just basically algebraically calculating rise over run. So we're saying, okay, this y value minus this y value, that's the distance y. This x value minus this x value is the distance of x. So that's where we get the 2 and 3 is rise over run. Okay, it's the same thing we're calculating here. Okay, just we're doing an actual calculation. We're not just counting. We're doing negative 5 minus 5. Well, that's negative 10. Over negative 8 minus negative 4. Be careful here. That's just going to be negative 4. We have a negative over a negative, which is a positive. 10 over 4. I can actually divide by 2. So that gives me the positive fraction 5 over 2. Okay, number 4, same exact thing. So let's look, if you know the formula, and notice what I'm doing every single time here is I'm writing the formula every time. Because as I've said, this is a formula that you need to know. You're not going to be given this on any type of test, SOL test or otherwise. I'm not going to give this to you on a quiz. This is a formula you need to know, okay? Because you kind of got to understand how it works. What this y2 minus y1 is telling you how far up or down you're going. This x2 minus x1 is going, well, from here to here, how far up or down am I, or left or right am I going, okay? So, once again, y2 minus y1, 4 minus 0 over negative 2 minus 10. Once again, this is because I'm saying this is 0.1, this is 0.2. 4 minus 0 is 4 over negative 2 minus 10 is negative 12. I have a positive over a negative, which is a negative. I can divide both 4 and 12. So this is kind of something I'm taking liberty with. I'm kind of assuming everybody knows how to simplify a fraction. I can divide both top and bottom by 4, so that gives me the fraction 1 over 3. So negative 1/3. Like I said, that's all there is to it. But let's go ahead and look at numbers 5 and 6. These are the ones I'm going to go ahead and say these are the special cases. You can kind of see something's up here because what do you notice both y values are? Well, they're 9. So when we plug into the equation or to plug into the formula, both of these y values are going to be 9. Well, what's 9 minus 9? Well, that's going to give you 0. Okay. So once again, we get y2. Once again, I'm saying this is 1, this is 2. You can flip it around. It actually doesn't matter. But in this case, the way I've labeled it, 9 minus 9 over 3 minus 5. So what does that give us? That gives us 9 minus 9 is 0 over 3 minus 5 is negative 2. Once again, this is where we have to know about fractions. But I want you to look at this fraction and look at this fraction. 0 over 4, well, we said that was 0. So 0 over negative 2, well, that's also actually just going to be 0. So that's actually 2 points that are on a horizontal line. And one thing that gives it up is each point has the same y value. So you can kind of think of them being at the same y value, so the point's going to be straight across. The opposite is true with number 6. If we look, we can kind of see, oh, the x values are the same this time. Well, what happens when the x values are the same? Well, y2 minus y1 over x2 minus x1. Well, that's going to be 5 minus 8 over -7 minus -7. And this one can be a little tricky. So we get 5 minus 8, that's -3, over, gets a little tricky here because we have -7 minus -7. I guarantee there's a lot of people that would say that that's -14. But if you're really thinking about it and you're clever about it, we have a number minus itself. Well, what's a number minus itself always got to be? Well, that's always got to be 0. Another way to think about it is we're subtracting a negative, so -7 plus 7 is 0, because you can think of subtracting a negative as adding the positive. But after we get through that, once again, I'm kind of rushing through that because I'm hoping everybody at this point kind of understands how to add numbers, whether we add and subtract numbers, in this case, subtract numbers, whether they're negative numbers or positive numbers, shouldn't matter at this point. Especially if you have a calculator, this should be easy. So literally you can just type this in and say -7 minus -7. It'll tell you it's 0. Okay. But here we go. All you got to do is -3 divided by 0. That's actually equal to nothing. So you can kind of just X it out and just say that that's undefined. Or sometimes you'll see this written as no slope. Because once again, we have a number on top, but our numbers on the bottom is 0. And if ever your number on the bottom is 0, that is undefined slope, meaning you have a straight up and down line. Okay, so you can see the common thing with all of these: straight up and down line, denominator 0. Straight up and down line, denominator 0. Okay, so that means if the denominator is 0, this is a straight up and down line. So these 2 points make a straight up and down line. Okay, so same as the last little section there. I suggest everybody go from numbers 7 through, if you flip over on the next page, there's actually 12 through 12 of these. So go through 7 through 12 here. So do 6 questions. Try all these on your own. Okay. I do suggest writing down the formula every time, but try these on your own and then come back to the video. So pause the video or close the video or whatever, but come back to the video and just check yourself and make sure you're doing these correctly. Okay. So I'll pause here a second to give people a chance to pause. And like I said, pause it, work on these, and then come back and check your work. All right. So hopefully people have paused and done this, but let's go through and figure out these out. Okay. y2 minus y1 over x2 minus x1. Well, same exact thing. Okay. y2 is 3 minus 9 over 2 minus -1. Notice when I plug in my negatives, I am using parentheses here, so I don't think it's like minus 1, okay? Which that doesn't make any sense anyways, but just it's always good to use parentheses with negative numbers just so you don't get it mixed up and think that you're double subtracting or you're adding or subtracting when you're actually multiplying or something. But in this case, it's subtracting a negative. So what we have here is we have 3 minus 9 is -6 over 2 minus -1. It's again a little tricky there, but I'm hoping everybody understands 2 minus -1 is technically the same as 2 plus 1, which is 3. Negative over a positive is a negative. 6 divided by 3, well, we can actually divide both of these by 3, and we get 2 over 1, which we can actually simplify again and just say that that's -2. We could have also seen that 6 divided by 3 is 2, so -2 is our slope. and that is our slope simplified. If you left it as negative 6 over 3, that's going to be counted wrong because in capital letters over here, always simplify fractions. So if you've got a fraction, you need to know how to simplify it. Okay. Number 8, m is equal to y2 minus y1 over x2 minus x1. Negative 2 minus 13 over 6 minus negative 4. So here we go. Negative 2 minus 13 is negative 15 over 6 minus negative 4 is 10. Negative over positive, so our final answer here is going to be negative 15 over 10. We can divide both of these by 5. So we get 3 over 2. So the slope here is negative 3 over 2. And the last 4 here, so I'm going to do something a little bit different here. I know I told you to write out the formula every time, but that's so you can practice and get used to the formula. I just want to show you how quick this can be. If you know the formula and you know the order here, you can kind of see the way to do it. It's the same every time. So I'm going to take 5 minus 6 over 6 minus 5. Now this one is a little tricky, I do admit, because you got 5s and 6s everywhere. But just keep in mind, call one of them 0.1, one of them 0.2, and that's the order it comes in. So 5 minus 6 over 6 minus 5. So 5 minus 6, that's negative 1, over 6 minus 5, that's 1. Negative over a positive is a negative. 1 over 1 is 1. Okay. So like I said, it can go pretty quickly if you know the formula. Same thing here. We're going to have negative 4 minus negative 4 over 1 minus 9. Now, like I said, I just know the formula now, so I can just plug in like this, no problem. But until you know for sure the formula, I strongly suggest writing the formula out every time. But once again, it also might help to label these. So you got negative 4 minus negative 4, that's 0. Over 1 minus 9 is negative 8. 0 over negative 8, that's just 0. So the answer number 10 is 0. Number 11, we're going to have negative 2 minus negative 9 over 3 minus 5. Well, negative 2 minus negative 9, that's actually positive 7. That's kind of a tricky one, I know, okay? But then that's going to be over 3 minus 5 is negative 2. Simplify this. There's really not much you can do to simplify this, but positive over a negative, the whole thing's going to be a negative. And we can't simplify 7 over 2, so it just stays 7 over 2. And the last one of these, okay, well, same exact thing. It works the same way every single question in this section did before. It's going to be 8 minus 6 over 4 minus 4. 8 over 6 is 2. Over 4 minus 4 is 0. Once again, a number over 0 or anything over 0, it actually could be 0 up here. 0 over 0 would still be, so that's actually not equal to anything. So that means this is undefined. Okay. So once again, just be careful of that. The main thing about this is know the formula. And I hope I was very clear. I was clear enough to where people don't get tripped up by the 2's and the 1's here. Because once again, the 2's and the 1's just tell you which ordered pair you get. They're basically like labels. Okay, it's basically like you had a label maker and you're just like, all right, I'm going to stick a label of 1 on this point. I'm going to stick a label of 2 on this point. So that's what these little these 1's and 2's are. They're just labels. They're saying it's the y from the point that I labeled 2. It's the y from the point that I labeled 1. Okay, and vice versa with the x. Now, The last part of this, and this is going to be the trickiest part, so we got a few examples to go through here. This is going to take probably the most time. I know this is kind of already a long video anyways, but if you know the slope formula, okay, you can actually work backwards and complete ordered pairs using a given slope. So if you already know the slope of a line, so basically if you know the rate of change, you can actually work backwards and be able to tell what one of the original points were, okay, if you know the other point. So what I mean by that is the example they give here is if the slope of a line passing through the points -5, 6 and 5y, so the key here is they told you this is y. We don't know what y is, so that's actually what we're looking for. We need to know what this point is, okay? But we know the slope is -4/5. You're asked to find y. So what do we have here? Well, this is in the slope formula section, so we're going to start off with the slope formula. Well, what do we know out of this formula? We know m is -4/5. We know y2 in this case, the way it's ordered here, so we can do 1 and 2. Well, it's y minus 6 over, in this case, x2 is 5 minus -5. Okay. Well, in this case, this can get a little tricky here, so you really got to pay attention. Okay, so we got -4/5. Well, I'm going to do something here. It'll make sense why I want to do it here in a second. But I'm going to put the negative with the 4. If you know how fractions work, if the whole fraction's negative, you can kind of move that negative with either the top or the bottom. But I'm going to move it with the top. So, and if that's something you always want to do is move your negatives to the top, that's fine. Y minus 6, we can't do anything there. But I can do 5 minus -5. That's just 10. And if you're very clever about it, this is exactly the same. So this looks the same now as a type of equation we solved earlier on in the year, which are, and this might give it away, which are proportions. So there's a little butterfly. Okay. Well, what does that mean? Well, that means we take 5 times y minus 6 and set that equal to -4 times 10. Once again, so this is a proportion. So when we talked about proportions, this is part of the reason why we talk about proportions is you can actually use it here to solve, because now when we distribute, we get 5y minus 30. So once again, we distribute the 5 is equal to -4 times 10. That's going to be -40. And now we just have a two-step equation. And I'm going to breeze through the two-step equation because that's not what this focus is about here. And everybody at this point should know how to do a two-step equation. If you don't, then you're going to struggle with what we're going to do going forward, okay? So we work out the two-step equation. We get that y is equal to -2. But what does that even mean? Well, that tells us the 2 points we have on our line, okay? This means my 2 points on my line are the first one, which we already knew, -5, 6, and now we know the other point is actually 5, -2. Okay, and that's what we're actually doing with these types of questions. So notice that was kind of a lot of work, but if you get good with this, it's actually, once again, this question, the next few questions we're going to do all work the same as what we just did. So the next, I guess it's 8 questions you have, okay? It seems like a lot, but once you get better with it and then once you see how this works, they actually all work the same way. Although I am going to give you a hint around number 16, so I'm going to put some stars by that one because I'm going to give you a little hint and a little trick that you can use to work ones like number 16, 17, 18, 19, and 20 because they kind of have something a little weird that kind of makes it a little harder if you're not paying attention, okay? But let's jump into it. Number 13, we have the points -3, -2, and x6. Well, in this case, we want to know what x is. So we want to finish that ordered pair, but we know the slope is 2. So what I'm going to do is I'm going to start off with my slope formula and plug in what I know. Well, what do I know here? I know m is 2. I know y2 is 6. I know y1 is -2. I know x2 is just x minus -3. So I can clean this up a little bit. One hint I want to give you here is this 2, it's not a fraction, but I can write it as 2 over 1. 6 minus -2 is 8. X minus -3, well, I'm going to make it easy on myself here. Instead of having x minus -3, so subtracting a negative, I'm going to write this as x plus 3. But now what we can do is cross multiply. So we have 2 times x plus 3 equals 1 times 8. Okay. And once again, at this point, that the hard part's over in my mind, because at this point, it's just a matter of distribute and solve a two-step equation. X is equal to 1. So once again, what does that mean? My 2 points are -3, -2, and the other point is actually 1, 6. Okay? So that's what that means there. So like I said, don't get too flustered here. This is a lot of stuff going on, but to me, the hard part is plugging in what you know, kind of manipulating it in a way, but then after you do the cross multiplication and do the proportion, it literally just becomes a two-step equation, and most of the time, two-step equation. And like I said, hopefully everybody at this point knows how to solve a two-step equation. So number 14, same thing. M is equal to y2 minus y1 over x2 minus x1. Well, what do I know from up here? I know m is 3 over 2. I know y2 is -7 minus -4 over x2, which is x, minus 0. So let's clean this up a little bit. All I did was plug in what I know up here. So let's clean this up. I can't do anything with the 3 halves. So let's keep it 3 halves. -7 minus -4, well, that's going to be -3. X minus 0 is just x. Well, this is actually a pretty simple proportion. We have 3 times x. And this is actually going to become just a one-step equation pretty much. 3 times x is equal to, well, 2 times -3. I'm going to go ahead and skip and say that that's -6. So now all I got to do is solve a one-step equation. So x is equal to -2. Okay. So there we go. And once again, that's actually as far as you got to do it. That's the answer. But I just want to point out what that means is the 2 points that I have now are 0, -4, and in this case, the x is going to be replaced by -2, -7. Okay? And that's all that means. That's all we're doing is we're basically working backwards and saying, what is this point? What is this point? Well, if we know the slope, then we can use the slope formula to figure that out. Number 15, same exact thing. M is equal to y2 minus y1 over x2 minus x1. We know m is -9 halves. That's equal to y minus -4 over -5 minus -3. So same thing we did with basically number 13 there is, or or the very first example where the slope was -4/5. I can move this negative, so I'm going to move it to the top. So I'm going to make it negative 9 over 2. Y minus negative 4, that's y plus 4, over negative 5 minus negative 3, that's going to be negative 2. Okay, once again, double check that. Make sure you're dealing with your negatives correctly. Okay, but that's, to me, that's all the hard part. Now it's just a matter of cross multiply. So we're going to have 2 times y plus 4 is equal to negative 2 times negative 9 is 18. So distribute the 2. 2y plus 8 is equal to 18. Subtract 8. Two-step equation time. 2y is equal to 10. Y is equal to 5. Which once again tells me, what do I have? I have the point negative 3, negative 4. That's the one they gave us. And now I know the other point is 5, or negative 5, 5. But then we run into something like number 16. So I'm going to put a couple stars by this one, okay, as I normally do with important examples, because what we see here is we're given the first ordered pair is x comma 2 and the second ordered pair is 6 comma 3. Well, I'm going to give you a big hint here is let's actually call, and this is something you always want to do, always call the ordered pair that has the variable in it, always call it the second ordered pair. And you'll see why we want to do that in just a second. Because if we write out our formula, so let's do that. x2 minus x1. Probably by the end of this, you'll be sick of this formula if you've written it down as many times as I have. But this is the formula. Well, now let's plug in everything. So we got negative 1/2 is equal to y2. Well, in this case, like I said, I'm going to call this one 2. So my y2 in this case is going to be 2. Minus y1 in this case would be 3 over x2 x minus x1 6. Now the whole reason I wanted to do that, let's reverse the roles here. Well, if we did it the other way, it would be 3 minus 2 up here, but then we would have 6 minus x down here. And I don't like having my things flipped around. So we can actually see this from the start, and that's my big hint to you is whatever ordered pair has your variable in it, always call that your second point. Because now the x is up front, and now when we simplify this, same kind of thing, I'm going to put the negative up front, up top. 2 minus 3 is negative 1 over x minus 6. Now when we cross multiply, we get negative 1 times x minus 6 is equal to 2 times negative 1 is negative 2. So we get negative 1x plus 6 is equal to negative 2. Minus 6 minus 6, negative 1x is equal to negative 8. Divide by negative 1, divide by negative 1, x is equal to positive 8. Now, you would have gotten the same thing if you would have kept the ordered pairs in the same order, okay? But like I said, it actually doesn't matter which one you choose, so my big suggestion to you is always, always, always make whatever ordered pair has the variable in it, make that your second ordered pair, meaning that's the one where your y2 and x2 come from, okay, from this ordered pair. So once again, what that means is now we're going to have the ordered pair 8, 2, and the ordered pair, the other one is 6, 3. Okay. Now number 16 or 17, 18, 19, 20 all work the same way in that you see this first ordered pair has the variable. I'm going to call it 2. I'm going to call this one 2. Just because when I plug in my formula, it actually makes it easier on me and I don't have to worry about things being flipped around. So in this case, I would have negative 4 is equal to, in this case, y minus negative 7 over, in In this case, once again, got to be careful here. X2 in this case would be negative 3 minus 1. So clean some things up. We would have negative 4 over 1 is equal to y plus 7 over negative 4. Cross multiply here. Well, this is actually pretty nice. 1 times y plus 7, that's just going to be y plus 7. Negative 4 times negative 4 is 16. Well, all we got to do is solve a one-step equation this time. And there you go. Y is equal to 9. So once again, that tells me I have the points negative 3, 9, and 1, negative 7. Like I said, don't get overwhelmed or frustrated by this, okay? All we're simply doing is we're basically working backwards from what we did before. If you're given 2 points, you can find the slope. But if you're given a point in the slope, you can actually find the other point. Okay, so 18. So just to rush these through really quickly. Like I said, these are pretty tough, but if you follow along with me. Once again, I called this 1.2 because, and if it even helps you, like erase them or write them down in a different order. So in this case, number 18, I'm actually just going to erase these 2 points just so I can, if it's confusing you about the points being flipped around, well then make this, the first point, 11, 8, and make this point x, 7. Okay, so that way now you can just call that point point 2 and that point point 1. And then that way, all right, let's fill this out. Negative 1/5 equal to y2, which is 7 minus 8 over, in this case, x2. The whole point, we want the x to be there, minus 11. So to clean this up a little bit, I'm actually going to put the negative on the bottom this time. And you'll see why maybe I want to do that in a second. 7 minus 8, well, that's negative 1 over, well, that's just x minus 11. Now we cross multiply. Okay, so what we get here is 1 times x minus 11, that's x minus 11. Negative 1 times negative 5 is 5. Add 11, add 11. X is equal to 16. So once again, that's the answer. We can stop there, but I just want to make it very clear. What that means is now that x coordinate is, or that x that we just solved is the x coordinate for this second point. Okay. Okay, so last two here, and then we're done for this, is same kind of thing. If these 2 points are tripping you up, this one has the y. You see the y here. Well, I want to make that my second point. So like I said, if it helps you, actually physically move them around. Rewrite the point. So we would have the point 0, 5 and the point 4, y. All right, once again, we go here. M is equal to y2 minus y1 over x2 minus x1. So we get 3/4 is equal to y minus 5 over 4 minus 0. So in this case, let's clean this up a little bit. We can't do anything with the 3/4, but we can do, well, we can't do anything with the y minus 5, but we can do 4 minus 0. That's just 4. And then we just cross multiply. So we get 4 times y minus 5 is equal to 4 times 3, which is 12. Distribute the 4. 4y minus 20 is equal to 12. Add 20. Add 20. 4y is equal to 32. Divide by 4. Divide by 4. Y is actually equal to 8. Like I said, I'm kind of breezing through this two-step equation stuff because, once again, everybody in here should know how to solve a two-step equation by now. But once again, that's the answer, but what does that mean? Well, that means I've got the point 0, 5, but I've also got the point 4, 8. Okay, And then the last one, same thing, except for in this case, I'm just going to label it so you can see you don't have to move the points around. You can just keep them there. But I am going to label this one 0.2 because it has my variable in it. So once again, why do I want to do that? So that way when I plug in, I'm going to plug in here. So we're going to have 1/3 is equal to, well, my y2 is then going to be y. When I plug in my y, it's going to be first here, minus -2 over -3 minus 9. So to clean this up, y minus -2, that's y plus 2, over -3 minus 9, that's -12. And we just cross multiply. So we get 3 times y plus 2 is equal to -12 times 1, which is -12. 3y plus 6 is equal to -12. Minus 6 minus 6. 3y is equal to -18. So my y in this case is going to be 6. Or actually, I almost made a boo-boo there. Negative over positive, it's actually going to be -6. Once again, what does that mean? That means my 2 points now are -3, -6, and 9, -2. And that is it for this section. So as you notice, the homework kind of short for all that we've done in this section, because if you look, it's actually only one page. But I do want to draw your attention to the next page. There is a little tic-tac-toe activity, okay? And that would be something that if you had a friend or you wanted to do it online, if you're an online student, we're going to do this in class. So as far as that goes, that's something we'll do in class, just a fun little activity to kind of just see if people are calculating slope correctly, okay? So just some extra practice, little activity. But the main thing is the homework. So you can see it's only 15 questions. Honestly, the first 12 questions are, in my opinion, pretty easy. Numbers 1 through 6, you're just doing like what you do back here is you just count, okay, to get the slope. Numbers 7 through 12, you do what you do here and you just calculate the slope by using the slope formula. And then the last 3 questions, and notice it's only 3 questions, it's only 1/5 of the thing. So even if you miss all 3 terribly, you're still going to get an 80 on this if you get everything else right. It's the types of questions where you're going backwards. And this is where I imagine people have the most trouble. But what I want you to remember is, okay, I'm going to give you a hint. Numbers 13 and 14, do this thing where you make point 2 or the first point, technically your second point. So point number 2. Because if you do that, then when you label it in there, it actually makes it really easy to do the equation afterwards, okay? But you got to know how to deal with proportions. You got to know how to deal with fractions. You got to know how to deal with negative numbers and subtraction, okay? But like I said, easy ones, numbers 1 through 12. Hopefully everybody can get every question right on that, okay? But then I can understand maybe if there's some problems with 13 through 15, but give them your best shot and we'll see what you come up with, okay? So with all that being said, if you'd like to try the activity, the tic-tac-toe activity with maybe a parent or, you can print it off and maybe try to do a little tic-tac-toe. Like it's more like a Connect 4 type thing. But try to go through and it's kind of like Connect 4 tic-tac-toe hybrid there. But you could try that out, get some good practice in calculating slope. I don't want it to be lost on this. All we've been doing here is dealing with slope. So it's talking about how steep a line is. So basically, how steep a line is, which can tell you in a real world situation a rate of change, meaning it can tell you speed or, how much money your bank account earns over an amount of time, or how fast a bird's flying, or how many gallons of milk a store sells in a day. Okay, once again, it'll tell you some sort of rate of change. But with all that being said, like I said, if there's any part of this video it's confusing, I know it was a long one. I'm going to try to wrap it up now. But if you, as always, if you have any questions, any problems, run into any issues whatsoever, please let me know. And as always, thank you for watching.